Welcome to the new year and welcome to chemistry. For today's getting our brain active and ready to start our thinking and sharing and collaboration, communication, we're going to start with a little brain activity where you'll use the images to create a word or a phrase. So actively think of what you see and say it out loud or type it down, write it down. What do you see in this image? And the term or the phrase that we're looking for is fading away. So making observations and writing down what you know can lead you to the answer or to the solution. It's that process that we're looking for. So that's that brain activity. Let's move on to our January calendar, something that we've been looking at over the past couple of days. We have entered the new year and we are nearing the end of our marking period. So today, January 6th, is a half day. Our morning classes were live and our afternoon classes will be asynchronous, meaning those classes in the afternoon will have assignments due, but you can do it on your own time independently. We do have a couple more of those throughout this month. The 6th, the 13th, the 20th, and the 27th is also a half day. This week we are finishing up with some big concepts. Next week we will review for our exam, and the following week is the final exams, 19th through 22nd. End of the marking period is January 22nd. This is when all of your missing assignments, any credit recovery projects should be handed in and are due that day. For today's learning goals, we're going to continue reviewing isotopes and using half-life information to solve problems. There is a warm-up in our Schoology page, week 9, Wednesday, January 6th, and you can pause this video to go do that warm-up. First quarter, or through this quarter, we've been creating these subatomic particles. We know that the proton and neutrons are collected or found in the nucleus, while electrons are found outside, or we can think of exit, E for exit, on the outside. Protons and neutrons have a mass of 1 AMU. AMU is the unit or atomic mass unit of how heavy those subatomic particles are. And again, electrons are negligible mass. They're so small, it's insignificant in determining the mass. Protons are positive. Neutrons have a neutral charge or no charge, and electrons are negatively charged. These are important profiles and descriptions that you will need to know for our final exam. We've been really focusing on isotopes, and remember that isotopes are atoms that have the same atomic number or the same number of protons, but have different mass numbers, and that is due to the change in the number of neutrons. What is radioactive decay? So we're getting into isotopes here. There are two types of isotopes: stable isotopes that do not break down and unstable isotopes that do break down, or are called radioactive. A radioactive isotope is an isotope of an atom that can release energy as it breaks down. So by doing this, by breaking down, we call this process radioactive decay. Each radioisotope breaks down at a different speed or rate, and that rate is called half-life. The half-life of a radioactive substance is the amount of time it takes for half of the substance to decay. So if we look at this isotope, cobalt-60, we see that the initial amount that we start with at 0 is 10 grams. 100% of that isotope exists. After one half-life, which is equal to 5.27 years, that 10 grams decreases into 5 grams. Another half-life passes, another 5.2 years, and that 5 grams turns to 2.5 grams. So what's happening during this decay? Let's pick up where we left off yesterday. So we did this example where we have an isotope, americium-242, and we start at 24 grams. Over the first half-life of 6 hours, half of that isotope will degrade or decompose or decay. So half. To get half, we divide 24 grams by 2. Half of that americium-242 will degrade, and we're left with 12 grams, or 24 divided by 2. What happens when the next half-life passes? We start off with 24 grams, a half-life passes, or 6 hours, and 12 grams of that isotope are left. What happens after another 6 hours? How much of that radioactive isotope are we left with? We can divide this number by 2, and we have 6 grams left after the second half-life. So how many hours total have passed from 24 grams to degrade down to 6? We can add those 6 hours together to get 12. After 12 hours, that 24 grams will break down into 6 grams. How many half-lives have passed? And we can count that: 1 half-life, 2 half-lives. So 2 half-lives have passed, or 12 hours, and that isotope breaks down from 24 grams to 6 grams. So let's take a look at a less visual half-life problem. Here we have sodium-24, an isotope, that has a half-life of 15 hours. The following table shows the decay rate if we start with 64 grams of sodium-24. So in this table, we have the number of half-lives, the time, and the mass number of that isotope, how much of that isotope we have. When we're given these types of problems, using the tools we have is pretty important. So highlighting information, the number of half-lives, we go from 0, 1, 2, 3, 4, 5, 6, 7. The amount of time, for every time that passes, we are adding 15 hours, and the mass number of that sodium is listed for each half-life that passes. What we're given in that statement is that the half-life of sodium-24 isotope is 15 hours. And we start with 64 grams. So with that information, I want you to think about these couple of questions. Why do we start with 0 half-lives in this first column? And the answer goes back to what we are being told in that first statement. We start with 64 grams. So if we start with 64 grams, no half-lives have passed, so we have 0 up top. How much time is added to each half-life, and why? So as we go from 0 to 1, 1 to 2, how much time are we adding to each step? And if we look at our table and what we know, the half-life is 15 hours. For each half-life that passes, we're adding 15. So from 0 to 1, we add 15 here. From 15 to 30, we're adding 15. Every time a half-life passes, we're adding 15 to the time that has passed. 30 plus 15 is 45. 45 plus 15 is 60, and so on. Third question. How much does the mass of the radioactive isotope sodium-24 decrease for each half-life? So how is 64 changing to 32? What's happening? So going from 64 to 32, you might say that there's a difference of 32. If we subtracted 64 minus 32, we have 32. So we know that 32 is half of 64. So every time a half-life passes, we're dividing this number by 2, or multiplying it by 1/2. 64 divided by 2, we get 32. 32 divided by 2, we get 16. 16 divided by 2, we get 8. 8 divided by 2, we get 4. 4 divided by 2, we get 2, and so on. So this is the same process that you will use to answer questions on your own. We'll do one more problem together. Let's start with this problem that we're given and look at what we have. Manganese 56, the isotope, is a beta emitter with a half-life of 2.6 hours. What is the mass of manganese 56 in a 1.0 milligram sample remaining at the end of 10.4 hours?
So what this question is really asking is how much mass, how much of that isotope will be left after 10.4 hours. Let's review what we know. We know that the half-life of this isotope is 2.6 hours. We also know that the starting mass that we have is 1.0 milligrams. We want to know how much will be left after that 10.4 hours. So here in this table, we've already got a lot filled out for us. We have the number of half-lives going from 0 to 7. We have the time. For every half-life, we're adding 2.6 hours. 0 to 1, we're adding 2.6. Adding 2.6 to 2.6 and getting 5.2 and so on. And we're really looking for what the mass is after 10.4 hours, or 4 half-lives. So to determine the mass, remember that the amount of the isotope is breaking down in half. So we can divide that number, 1.0 milligrams, by 2. 1.0 divided by 2 is 0.5. Divide that in half again. Another half-life has passed. 0.5 divided by 2 is 0.25. We continue this process a couple more times. Eventually, after 10.4 hours, we get 0.0625 milligrams of manganese 56. For our practice problems, you will go to our Schoology page, week 9, Wednesday, January 6th. In that folder, you'll find a Nearpod practice problems, a link that you will click, and a code if you need it. A little refresher on opening a Nearpod. You're going to sign in using the Office 365. That is your PPS email. Directions for each problem are up top, and at the bottom you have tools such as the marker, pen. You can change the color or the size of the marker and pen, and you will use this to answer the question. Go ahead and get started on those 2 problems, and we will take time tomorrow to review them.